Today we're going to cover Chapter 5, Section 3. We're going to learn properties of logarithms. So if you have the newer calculator, remember what you're going to do is you're going to hit the math button. Then you're going to scroll down until you see the option that says log base. Then you're going to enter in the numbers. It'll open up something that looks like this with the boxes. You fill them in and you hit enter. If you have the older calculator, then you're going to set up this ratio. So for example, if you were doing this question, you're going to put the bigger font number. So the 23 looks like it's a bigger size. So it go on the top, log 23, divided by the smaller font, log of 3, and hit enter. Now, I heard someone else teaching this, and they said that what they do is the number that's a little bit higher than the base, like that one's up a little bit more than the base is like a subscript, that one goes on the top, and then the base goes on the bottom. You can also use the ln button, okay, but you have to stay consistent. You can't do log of 23 in the top and then hit the ln button for the denominator. You either have to do ln for both the numerator and the denominator, or the log button for the numerator and the denominator. It doesn't matter. When you do the homework tonight, you're going to round it to 3 decimal places. So for example 1, it says to rewrite it as a ratio of common or natural logs. So what that means is you're going to write log 25 divided by log of 4, and then you're going to hit enter after you divide this. Now, if you have the newer calculator, you don't have to do this, but if it asks you to write it as a ratio, this is what it's expecting. I'm going to go ahead and round to 3 decimal places. So 2.322. Okay, now when you do these problems, the answer that you get should make sense. So if I were to go ahead and take my problem and add an equals x here, and now do my bay, and 4 to what power gives you 25, it should make sense, because 4 squared is 16, 4 to the third is 64, so 2.3 is somewhere in between 2 and 3, and then that would have given you the 25. Also keep in mind that when you do the change of base, you can also use the natural log button. You could also do ln of 25 over ln of 4. You're still going to get the same answer. For the next one, again, the ratio would be log of 12, log of 2, and this will be approximately 3.585. If you're going to just use this ratio, what you're going to type in your calculator, you'll hit the log button, it'll open a parentheses, and then you're going to do divided by, then it'll hit the log button again, put the 2, close the parentheses, hit enter. Absolutely. So you don't have to enter it as a fraction, you can use the division. All right, so some properties of logs. So the first one is the product property. Notice in the parentheses here, the u and the v, they're side by side. This means they're multiplying. So when you go to expand it, we're going to separate and give each one of the terms here in the parenthesis its own log base a, or whatever the log is. Now, if you think about it, this is the opposite of exponents. So remember when you did a problem like this, like 2 to the third times 2 to the fourth? Remember when you multiply exponents that have the same base, you keep the base and you add the powers. So this is the same idea, but with logs. And remember when you divide exponents that have the same base, you take their powers and you would subtract them. So this would become 5 to the 7 minus 4 power, or 5 to the third. So for our quotient property, if your log is given to you as a division problem, to expand it, you take each part and you will add in the word log in front, and then you would subtract them. The power property, you're going to take the exponent and then you're going to move it to the front of the word log. So that's what they did here. They took this power of n and they moved it to the front. We're going to be using these properties in the next lesson when we go to solve log equations. Now, as far as condensing is what we're going to be doing. As far as expanding, you're going to be using these properties a lot in calculus, especially when you do derivatives. So these properties are going to come back to you. You will cover logs in pre-calculus and in calculus. Okay, so for the first example, this one, it just wants us to find the exact value. Now, we can do two things here. We can either use what we've already done, convert this from log form, where it's spelling bay, to exponential, and we can do 5 to the x is equal to the cube root of 5. Change it so that they have the same base, so we can do the 1-to-1 property. So this would become 5 to the 1/3 power. Now that the bases are the same, then we have x equals 1/3. So this was just finding the exact value, just doing what we had done before. The thing you could have done is we could go ahead and convert this right here and make it 5 to the 1/3 power. And we can apply our power property that we just learned. And we're going to go ahead and we can pull the power to the front. It becomes 1/3 times the log base 5 of 5 equals x. So here, if you recognize that the log of base 5 of 5, this is just 1. So then really what this becomes is 1/3 times 1 equals x. And this is another way that you could go about solving for x. Okay, so let's watch. So if I take log base 5 of 5 equals x, BAE, 5 to the x power equals 5, and then I can assume a 1 there, has the same base, get rid of it, and x equals 1.
So if it's the same number?
The next one wants us to expand the problem. Now, what's happening with the 5, the x cubed, and the y? What operation is being performed on all those? Multiplication. So when we go to expand it, I'm going to have some plus signs because that's what the product property says to do. So each one of these terms here is going to get its own log base 4. So I'm actually going to separate this into 3 different things. So I'm going to write log base 4 with the 5, and then plus log base 4 with the x to the 3rd, plus log base 4 for the y. Now, when you go to expand, you cannot have any exponents left or radicals. So what we're going to do is we need to take that power of 3 on the x, and we need to apply the power rule. So I need to take the 3, and I need to pull it to the front of the word log. The other ones are okay. They're done. So the first one, log base 4 of 5, is done. But this one, I'm going to pull the 3 in the front. And then it's now log base 4 of x. And then this one was done as well. So that is that log expanded. Notice the next one is a division. Now, is the 3x and then the minus 5 each going to get their own log, or is that together? It's together. Good. Because underneath the radical is like a grouping symbol. So what I'm going to do here is each one is going to get the natural log. So ln of the square root of 3x minus 5, and then minus, because this is representing the division, and then ln of 7. Now, when we're done expanding, no radicals. We got to get rid of that. So remember, whenever you have a square root, it's like raising it to the 1/2 power. So I'm going to change 3x minus 5, and I'm going to change this to 3x minus 5 to the 1/2 power. Still has the minus natural log of 7. And again, I can't have exponents left either, so this 1/2 needs to come to the front. So then the final answer is going to be 1/2 natural log of 3x minus 5 minus the natural log of 7. This one has multiplication and division. So what we're going to do is, let's just first, we can take, this is going to be a product in the numerator. So log base 3 of 4 plus log base 3 of x squared minus, for the division, log of the square root of y, and it's base 3. And then now I have to take care of the square root symbol and the exponent. So I have to move this to the front and then also change this radical to a 1/2 power. So it'll become log base 3 of 4, move the 2 to the front. Then I can change the log base 3 of y, the square root of y, make it 1/2, but then I still got to pull the 1/2 to the front. So then now final answer, log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. The expanding we're not going to use as much. You will probably get an expand question. However, the condense is what we're going to be using in the next lesson. So we have to now, if it's got multiple logs or multiple ln, we need to get it down so it only has the word log once or the natural log one time. So the next one. So now I'm going in reverse. So now my goal is to only have the word log one time. So notice it's got an addition sign, so that means multiplication. I also have some numbers over here in front of the word log, so those are going to go back as powers. Now it doesn't matter what you start with first. I think I'm going to pull the powers back first. So I'm going to put the 1/2 power back and the 3 back. So then this will become log of x to the 1/2 plus log x plus 1 cubed. Now, remember, 1/2 power, that's going to become the square root. So now, if you want to go ahead and condense it, or we could go ahead and turn this into the square root of x, and then now we can take care of the plus sign, and this is going to be multiply. So now I write the word log once, and then I take these two and put them next to each other. So I could do like a bracket. So the square root of x times x plus 1 to the 3rd. Notice this one has a subtraction sign. So this tells me I'm going to have division here. I could go ahead and take care of this power first. I can put that back. So I could do natural log of x plus 2 squared minus the natural log of x. And now I can take care of the division. So ln, and then it'll be x plus 2 squared over x. So you could probably not put the brackets here. I'm not sure if WebAssign is going to mark it wrong. But the brackets make it easier to read. All right, let's try number 9. Now, this 1/3 power, what's it going to go on?
1/3, all of it.
All of it, good. Okay, so what we can do is get log base 2, And then the plus sign means multiply. So you could take the x and then times the x plus 1. And then this whole thing is raised to the 1/3. And you should use, I guess, brackets here. So here would be brackets would be better. Parenthesis, then a bracket, because it's got to be around the whole thing. This is one where you would need the brackets. Now, we don't want to have any exponents left, so we got to turn it into the cube root. So it's going to be log base 2 of x times x plus 1, and this is all under the cube root. And you don't need a parenthesis around it now. The last one, this 2 in front, everything's going to be squared in the end. So we could go ahead and condense what's in here. It's a subtraction, so it's going to be division. So we're going to do x plus 3 over x minus 2, and we can pull that power back. And then the whole thing is also squared. So this 2 that was in the front here is the power that goes here. This 2 went back to here, and it ended up right here.
Wait,